To build a multi-billion-dollar enterprise, you don't hire one omniscient genius. You hire thousands of specialists, partition them into strict departments, and spend millions purely on managing their interactions. Why? The answer begins with the biological limits of human neurology. A single brain possesses finite working memory, processes information sequentially, and has a strict biological ceiling on its computational endurance. In 1957, Nobel laureate and economist Herbert Simon formalized this constraint as bounded rationality. Bounded rationality dictates that because we lack perfect information, infinite time, and unlimited cognitive processing power, we cannot optimize every decision. Instead, we satisfice. We accept solutions that are merely adequate to avoid paralyzing our workflow. That biological limit collides with modern economic demands. A smartphone requires simultaneous mastery of quantum physics, metallurgical engineering, and global supply chain logistics. To execute tasks that far exceed the capacity of a single human skull, the multi-departmental organization was created to distribute physical and cognitive loads across a vast, interconnected network. This structure allows the collective to process what a single mind cannot, transforming a massive, abstract objective into a series of executable steps. If extreme specialization is the goal, an obvious question arises. Why build a massive, extensive internal bureaucracy? A founder could theoretically remain a solo operator, subcontracting every individual microtask to independent specialists on the open market. That approach fails entirely at scale, a phenomenon explained by transaction cost economics. Operating in a pure open market incurs massive friction. Sourcing reliable talent, negotiating ex-ante contracts for every discrete task, and the constant policing of intellectual property requires constant, erratic effort. A solo operator would exhaust their cognitive bandwidth strictly managing vendor relationships, leaving zero capacity to actually build the product. By internalizing those specialists into a corporate hierarchy, the organization eliminates this friction. The unpredictability and opportunism of independent contractors are replaced by managerial fiat. You no longer negotiate a price for every email sent or line of code written. You issue a directive, and it is executed. Shareholders willingly pay the massive fixed costs of executive salaries and HR departments to secure a level of predictable coordination that the open market cannot guarantee. Internalizing labor solves open market friction, but it immediately triggers a new systemic failure mode, diseconomies of scale. As a firm adds employees to increase output, the amount of coordination required between those employees scales exponentially faster than the actual work being done. This model illustrates the combinatorial explosion of communication, governed by the formula n times n-1 divided by 2. 5 employees require exactly 10 paths to stay aligned. Apply that to 30 employees, and the network fractures into a catastrophic 435 independent communication paths. At this density, 54. A growing organization is mathematically forced to either establish rigid architectural boundaries or collapse under the weight of its own internal latency. To arrest this combinatorial explosion, the organization must implement its most vital structural defense, the formal division of labor. In 1776, Adam Smith observed that an unspecialized worker might produce 1 pin a day, but dividing the manufacturing process into 18 distinct repetitive operations allowed a small team to output tens of thousands. Modern firms apply this logic through organizational modularity. They decompose the chaotic web of employees into highly discrete subsystems, known as departments. This diagram shows how organizations isolate that chaos. Departments are structured as black boxes, boasting high internal cohesion and low external coupling. Dense coordination happens inside the module, while a single, simplified interface handles external requests. Guided by organizational information theory, these departments operate as specialized cognitive filters. They absorb ambiguous data, apply localized expertise, and output actionable intelligence. Because of the defined interface, an engineering team does not need to understand the algorithmic complexities of payroll taxes. They only need to know that submitting a timesheet guarantees compensation. This modularity reached its mature form in the 1920s, transitioning from heavily centralized workflows to the multidivisional, or M-form, architecture. By decentralizing the company into semi-autonomous product divisions acting as distinct profit centers, executive leadership could finally delegate daily operational fires and focus strictly on long-term strategy. The organization achieves superhuman comprehension because no single human ever has to comprehend the entirety of the system. But modularity is a fragile compromise. The rigid boundaries that save the firm from communication overload directly generate severe system entropy. The primary failure mode is the silo effect. Highly insulated departments lose horizontal alignment, leading to data fragmentation and duplicated efforts, and a focus on local goals over the holistic success of the company. This isolation creates a principal-agent problem. Specialized employees recognize that their actions are obscured from top executives. They begin optimizing for short-term benefits, hoarding departmental budgets, or coasting on the labor of adjacent teams. Because the C-suite cannot see inside these black box departments, they must hire thick, expensive layers of middle management whose sole function is to monitor, police, and force coordination between the silos. This dynamic guarantees bloat, governed by Parkinson's law. Bureaucratic managers naturally seek to expand their span of control, creating artificial work to justify hiring more subordinates and securing higher status. Ultimately, highly optimized departmental structures become totally rigid. They excel at sustaining current processes, but inevitably fall victim to the innovator's dilemma, rejecting disruptive technologies to protect established margins. This bureaucratic bloat functions as a mathematical tax, paid in overhead to stop isolated modules from drifting into total misalignment. By 2025 and 2026, the structural limitations of the traditional M form are finally collapsing under the integration of generative AI. Historically, the middle management layer existed almost entirely to manually route information and bridge the communication gaps between strict departmental silos. Large language models and AI agents do not suffer from bounded rationality or the working memory limits of Dunbar's number. By deploying an interoperable agentic web, firms are automating administrative reporting, synthesizing data instantly, and drastically increasing a single line manager's viable span of control. A severe Gen AI divide separates the market. A small fraction of mature companies have abandoned generic chatbots in favor of customized, autonomous workflows governed directly by line managers, bypassing traditional hierarchies entirely. When an individual contributor uses autonomous agents to handle research, drafting, and error checking simultaneously, they achieve superagency. A single worker effectively operates an entire functional subdepartment by managing AI execution instead of performing manual tasks. Artificial intelligence does not eliminate the necessity of the firm. It simply shifts the heavy burden of coordination from human bureaucrats to algorithmic layers. While AI compresses communication latency, the need to divide labor remains. The multi-departmental firm persists as humanity's most powerful engine for executing impossible complexity.